So thanks for joining us today, everybody. We're doing another Stainless Steel World podcast. I'm very happy to welcome today Rodney Rice, the Director at Langley Alloys. Rodney's an old friend of Stainless Steel World who's been involved in our conferences on the steering committees for Duplex World, spoken at Stainless Steel World as well, been very involved in the magazine over the years, and he is a fantastic expert on duplex stainless steel. So that's our topic for today. Welcome, Rodney.
Yeah, you made me a bit nervous with the use of the word expert.
Well, I mean, you do know a lot about duplex stainless steels, and one of the great things is you have a very nice way of telling people about duplex stainless steels. So let's get into that and see how this fantastic family of materials is being used.
Okay, let's go for it. I mean, it's got so many positive things going for it in terms of physical properties, mechanical properties, relative cost competitiveness against alternatives. It just opens up so many applications for the family of grades. Almost too many to go through in a way.
The great thing about duplex stainless steels for our listeners is that they combine the properties of both austenitic and ferritic stainless steel. So this means they have excellent mechanical strength, corrosion resistance, high durability. They're a sustainable material as well. One of the first areas where it became really popular, of course, was in subsea applications. Do you want to tell us a little bit about that?
You can't really look at the applications without considering some of the development of the alloys. And so with the early commercialisation, particularly of super duplex, so the 25 chrome grades, it was in and around the UK, and it was in and around the time where North Sea, deep sea exploration was starting to occur. So it found a really good fit in terms of oil and gas related, but not specifically the oil and gas tooling, but around pumps and seawater handling and the like. So it was that sort of combination of factors, the development work being done close to market, the existence or the creation of that new market, and the excellent fit of the properties and the intended applications. That was really the trigger or the initiation of a set of circumstances that encouraged the further development of duplex, initially as castings for things like pump bodies, but then subsequently into wrought products, into forgings for bars and plates, which can then get used as fabrications and machine components, and starts to really broaden the range of components. So from pumps and pump shafts into valves, into pipework, into heat exchangers, etc., etc.
Right. I know that with duplexes, we talk about the PREN number, the pitting resistance equivalent number, and I think, as you've mentioned before, that it's widely accepted that a PREN of 40 or above is ideal for long-term immersion in seawater.
I think so. Whether it's written into standards and specifications formally, things like NORSOC, or just as a rule of thumb. So particularly if it's a capital piece of equipment, something that you expect to operate for an extended period, almost not quite fit and forget, but it could be at the bottom of a seabed for many, many, many years.
Right.
And realistically speaking, once it's out there, it's very difficult to get it back. So having a degree of performance, comfort in performance over that extended period is what you need.
Right. And as I understand it, the good fatigue resistance of duplex also makes it ideal for subsea, because in those conditions, as you say, it's difficult to get them back, but they're subjected to forces of waves and currents, constant movement, let alone the pressure of the water. So fatigue resistance is also very important.
Well, fatigue resistance is important, but it's actually sometimes it's quite difficult to find good data. But I mean, a starting point anyway is just to consider the mechanical properties, the strengths. So because the tensile strength of duplex grades is really high, that already limits issues that may be associated with fatigue and long-term use and cyclic performance. So having a very high strength alloy base and then having that mixed austenitic ferritic grain structure really just helps all of those elements of those sorts of applications.
Now, Rodney, if we leave the subsea where it is and look a little bit up and go into the marine applications where we're at the surface of the water, I know duplex has a lot of great applications there as well.
It's probably a little bit more varied and sometimes maybe a little bit less obvious as well. So I think certainly some of the earlier applications would have been around marine shafts, so propeller shafts. To be honest, these days that tends to be an application that's more widely served in 22 chrome duplex rather than super duplex. Once you go beyond, I was going to say a simple propeller shaft, but that's not fair. You'll then get into water jets, pumps, a whole range of sort of fixtures and fittings that will go around the deck of the boat. But mainly, it's the stuff that's underneath the keel that won't be seen, the shafts and the rudder element and various other hardware. And we've got customers making use of both regular Duplex 22 chrome and super Duplex for components going into the sort of drive train, in a way, of a boat.
Right, where it needs that corrosion resistance and high strength.
Certainly high strength, and high strength will help limit the diameter of the bar, sort of torsional stiffness and rigidity. One thing that shouldn't be overlooked, really, Joanne, well, maybe two things actually while I'm thinking about it. One is availability. So compared to the 1970s, where this was a relatively novel product and availability would have been less straightforward. These days now it's more widely available, more widely understood, more widely accepted in terms of its processing and fabrication. So that's one. And the other one, we can talk about strength and corrosion resistance, but it is the relative pricing point as well. So if you're coming from a perspective of using carbon steel or more simple, like 300 series stainless, it can feel relatively expensive, twice the price.
Right.
But comparing that with, super austenitics or nickel-based grades, it's maybe half, a third, a quarter of the price. So getting all of that great performance and that long-term lifetime for a relatively modest cost increase is the thing I think that's really driven its more widespread use.
Right. So really the cost assessment over the lifetime of the product rather than just looking at the purchase price.
Absolutely. I know that's a difficult one. I think the thing that helps, or has helped, Joanne, when we talk about these sorts of oil and gas, subsea or marine applications is it's the corrosive environment, actually. It's very difficult to find something with that level of corrosion resistance without incurring way, way higher prices. Or using alloys which just haven't got the strength, the physical properties to perform. So it's such an easy, convenient fit in a way for those applications it does routinely that you have to go out of your way to find an alternative family of grades.
And I think with construction as well, people think, okay, construction's on land, but actually a lot of infrastructure and buildings are actually a marine environment because they're so close to the coast. And I think perhaps that's an area that has been overlooked for a long time, that, if you've got rebar and bridges or road structures or your buildings that are built next to the ocean somewhere, within also quite a few kilometres from the coast, Duplex could offer actually a very cost-effective alternative to, especially to carbon steel, to make structures last for much longer.
I think what you see there once you talk about coastal application, it's construction, but it's built on the edge of land, so it's not full-time, long-term immersion in seawater, but it's a highly corrosive environment, and it's certainly very aggressive. And if you're using regular carbon steel, grades of steel which are not inherently corrosion resistant, then you spend a lot of time, a lot of effort and a lot of money rust-proofing them in a way through metallic coatings, through paint organic coatings, through lengthy sort of maintenance and inspection programs. So stainless in those applications for sure. It's all too easy to find and see failures in bridges and structures, and the safety critical element of those applications really should push a better choice of material up front. But I guess we only know now about the performance of lesser materials after 20, 30, 40 years in service, and unfortunately some failures. But you can take the other end, the other extreme in a way. There are applications where maybe Duplex is being selected as much about appearance. So from an architectural perspective, architects and designers like the aesthetic of bare metal, and they like that integrity in the choice of materials. So wood that looks like wood, metal that looks like metal, etc., etc. So having stainless steel where it's uncoated, unpainted, unfinished, maybe just polished or ground, they choose it for the appearance, but it gets around the fact that it won't need the maintenance, it won't need the coating, it will retain its sort of look and feel. It's strange in a way that we talk about construction and you have one application such as rebar where you don't see the product and it's purely about longevity, but you're talking about designing structures for 60 or 100 years.
Yes. And
then at the other extreme, you've got products which are all about the appearance, but they just happen to retain that appearance for 20, 30, 40 years, again, with minimal maintenance. So
with minimal maintenance, yeah.
Quite an interesting perspective there, that the same product can be used
Yeah, in different ways.
For very different reasons or in very different ways, yeah.
Yeah. Hey, Rodney, if we look into some of the other applications for Duplex, one, of course, that we can't ignore is the fertilizer industry, which is booming at the moment globally. Populations are growing. We need to feed them. We need more food. We need more fertilizer. Hopefully, we're using more Duplex.
I think so, absolutely. I mean, fertilizer industry in its own sense is a huge industry, and it's not fertilizer production being a single process, it's multiple different processes. So one route to producing fertilizers comes from effectively the mining of phosphate rock, and then that's broken down and processed using acid solutions, nitric acid, phosphoric acid. So the inherent corrosion resistance of Duplex ensures it can sort of easily repel the effects of nitric and phosphoric acid, and sulfuric acid as well, actually, in some processes. But also the higher strength, that toughness, high strength, good mechanical properties, gives it a level of sort of abrasion and wear resistance.
Right.
So we see applications for Duplex, super Duplex plate getting fabricated into tanks, into agitators, which are large mixers with blades on to break up and circulate solutions, into pipework, into pumps and the like. But then there are also processes which are more chemical in nature, generating fertilizers through the production of ammonia and urea. Mm-hmm. And again, you will have a lot of acid solutions.
These are really aggressive, corrosive environments.
Yeah, and where you've seen some really interesting development there, where a number of the manufacturers have created variations on Duplex grades specifically for certain people's technologies or certain people's applications. So you start to see trademark Duplex grades and stainless grades being used in that family of fertilizer production applications as well.
Right. So, Ron, if you look at slightly less aggressive environments, still corrosive, still needing high strength, if we look at water treatment, because this is I find this personally a really interesting topic for Duplex stainless steel, not only in terms of, the climate change is creating environments that lead a lot more desalination, but also more extreme weather conditions, and controlling water, handling and transporting water, treating water, it's all becoming much more important. And I can see that there's a growing use of Duplex around the world actually for these applications as well.
Yeah, if you think of, in the same way as we said construction, and we very quickly identified rebar at one extreme and architectural structures at the other, you've got the same thing with all things water. So you mentioned desalination. So there are parts of the world, Southern Europe, North Africa, obviously the Middle East, where they already have a scarcity of water and so rely on desalination. But I'm not sure if it would surprise you or not that even the UK, this little island in the west of Europe that's always cloudy and rainy, we even have desalination systems in the UK as well, because sometimes the water is in the wrong place. So yes. For desalination, I mean, that's a really interesting case study, because you start with seawater. So, alloys with Pren greater than 40 are perfect for almost the entry end. And as the water goes through whichever process it is installed, osmosis, reverse osmosis, for instance, it becomes progressively less corrosive an environment. So you can transition from 25 chrome to 22 chrome, for instance. We actually see a similar story with hydrothermal. I know I'll come back to water in a minute, but I've gone off on a tangent now.
That's okay. You do your tangent. That's fine.
Well, I'm thinking about salt water. Purification for desalination, for instance. But then I'm also thinking about hydrothermal, where you often have wells sunk into the Earth's core, and in that instance you're exposed to brine. So actually, supersaturated seawater. And that's been another application where Duplex, specifically super Duplex grades, have been the default selection.
Right. Becomes milder, so you need
so
less,
it's a little bit of a distraction, but we were talking about concentrated
water.
Seawater. So you actually see other processes with brine. So we think about taking seawater and taking the salt out of it, but at some part of the system, you've got a more concentrated...
you've got the brine left over. Which is very aggressive.
So
and if we move from If we move from water scarcity to too much water, of course we've got the flooding and the extreme rain events that we get now as the climate warms up. Hot air holds more water, starts raining, we get this flooding. We've seen a lot of examples of that in the last couple of years, both just recently in Texas, but also in Italy and Spain. We've had some really shocking flooding. Even the UK, actually, you guys have had some big flood events. So flood defences are becoming even more important, and I know that Duplex can play a role there as well.
Yeah, I think once you start to talk about water management in a way, thinking about lock gates or sluice gates or flood barriers,
yes,
and there is an opportunity to exploit the higher strength of duplex, super duplex grades, because they tend to be fabricated structures, so fabricated from sheet and plate. You don't quite get the same benefit of the higher strength and reducing the thickness. It's somewhat diminishing returns, but there is an advantage from the higher strength. But where you would see it is being able to reduce, almost completely avoid the need for continual sort of recoating or repainting of structures. So massively reducing the maintenance cycle.
Rodney, one of the last topics I wanted to talk to you about is perhaps one of the most important ones is renewable energy, because we see a lot more of it these days, from wind to solar to geothermal. Duplex, of course, can play a role as well in the energy transition.
Next development that I've seen quite strongly promoted at various exhibitions is floating wind.
Yes.
Where you have a structure floating, but you've still got to tether it to the seabed. So once you start to consider chains, connectors, swivels, anchor points, the various componentry in a way beneath the surface of the water, then you're thinking, well, I need high strength, I need long-term corrosion resistance in seawater, it's a relatively large structure, so I need to be mindful of the material cost. Duplex.
Duplex, the perfect one.
So, if and when applications like that start to grow in significance, then it won't be what you see that will use them, it's all of the stuff that you don't see.
Yeah, well, we'll continue to do our bit to promote it. I know you will as well. Yeah. I look forward to seeing you at Duplex World next year on the 6th and 7th of May in Rotterdam. I invite everybody to come and join us. It's a great event for the global Duplex stainless steel community. Rodney will be there as part of our expert steering committee, and we're expecting a fantastic lineup at the conference, so I invite everybody to come and join us. Rodney, thank you so much for your time today. It's been an absolute pleasure to talk to you, to learn more about Duplex stainless steel, and we look forward to hearing again from you soon.
Thank you very much, Joanne. Always a pleasure to shoot the breeze.
Okay, bye-bye.
Bye now.